The Purdue clock has been done here for many, many years, and the reality is that its true name is the Old Nassau reaction. The reason it's called the Old Nassau reaction is because this was developed at Princeton University. And the chemistry department, or chemistry building at Princeton, was titled Nassau, or Old Nassau. So that's where the title came for the reaction. Their colors were orange and black. Purdue's colors are yellow and black, and so we formulated this with the chemicals involved so that in the proper ratios the presentation should be yellow and black, which gives us the Purdue colors, or gold and black as we call it. So what happens is that you have mercury chloride, sodium bisulfite, and then the third component is potassium iodate. What happens in this reaction is that the mercury chloride reacts with the iodate and forms mercury iodine, which gives us the yellow complex, or yellow color to start with. There is also starch mixed in with that solution, and the iodate complex, starch iodate complex, forms a blue-black complex that's dark enough that the mercury doesn't disappear or go away. It's just masked by the deep color, and so it ends up giving you the yellow and gold, or yellow and black colors of Purdue in that reaction. It's a fairly small amount of mercury that's used to do the reaction, but it's still a heavy metal, and so you do have the precaution that you're going to have to take the whole solution and dispose of properly because of the mercury concentration. One of the benefits of being at a university like Purdue is we have an in-house group that takes care of this, and so we have a waste jar that every time we do this demonstration we dump it in there, and it has the necessary labeling on there to indicate how much mercury is present, and they simply come and pick it up when we request that the jar is full and be taken away. That is an issue that you would have if you do this demonstration in a classroom, because you are going to have a heavy metal waste that's a result of the reaction. That there is ways that that can be dealt with. There are hazmat companies that will pick up stuff and process this, but I'd advise you find out what the pricing is for that, because it is not inexpensive. And it may be over time that you can have a carboy or something that you store it in, and they get it in a set period of time depending on how much you use it, but you need to find out what that is. And the size that you do it really is going to factor in too. We generally do it, I scale it down. A lot of our color demonstrations, I'll do a liter total volume. With this one, because I know mercury's present and it's going to be a waste we're going to have to deal with, we tend to scale it down and don't do more than 600. Basically, it's A, B, C solutions mixed together, 200 of each, and so that gives us a 600 quantity that then we have to process. And so it's going to take a while to get a couple, 3 liters of that before we have to have it picked up to ship out. This has been called, as we've mentioned, the Purdue clock. The reason it's called the clock is because if we set up 5 demonstrations exactly the same and used a stopwatch, and we mixed A, B, and C solutions together and stopwatched each reaction, they would almost be the same time frame in each one of them, because the kinetics are such that they're like a clock. And so the same ingredients mixed together, it's going to present the yellow color, that's going to present the black color, and then that'll be it. But it's timed that way. And there are other reactions like this where they have been titled clocks because the researchers found when they mixed them together, they presented the colors, they did the changes, the reaction happened in a certain time frame, and the right concentrations mixed together the same way consistently gave you a clock-like reaction time and change, and so they're known that. The chemistry involved here, it involves kinetics and the whole changing of compounds and forming of compounds in the reaction. In some cases, the kinetics cause the compounds to be broken down and transition to another one and then move on to another one. In this one, we have one compound being formed and then another compound being formed, and that masks the first one, and so we see a color change because of it. The main safety concern here is the mercury, and it's not a problem being around it. You would want to wear your usual safety gear, your goggles, safety glasses. Gloves are a good process in this, but one of the things that's Advantageous is mercury is not something that is in a vapor form, which is more problematic. It's a liquid, and so getting it on your hands is not going to be a problem to your tissue, other than you want to wash your hands and don't put your fingers in your mouth or to eat food if you haven't washed your hands. Wearing gloves protects you that way, that you can take the glove off and now you have clean hands. Either option works, but that's the key that you have to be careful of with mercury.